Hello again. So we have reached exercise 9, which is to add an element to a hash table where resolution are resolved using separate chaining. So we need to insert the element at the end of the list. So I'll be using the same element, the same example. So we have also the same task. So we need to create the hash table and we need to insert and then print the hash table. So here we are using a linked list. So a list is defined by an element, which is an integer. You can replace it by a character, for example, or anything else, and extract a node to the next element, and we will call it this a list. So a hash table is an array of m list. So in order to create this table, this array, so I need to initialize each element to null. So int I, for I equal to 0, I less than m, I plus plus, and I just need to place in h of I null. So we have the hashing function, so you're not responsible of the hashing function, and then we need just to insert and to print. So in order to insert an element into this hash table, I just need to insert the element into the corresponding linked list. So it's the same as insert, so I need to write a function to insert an element into a linked list. So I will insert this NB, and I will insert this element into this linked list. So of course I will hash the element, and I will add an address since I need to modify the linked list. So we have here the insertion of a linked list, and we need to add not a push but to the end of linked list. So I will write it recursively. So I will add at the end of the list. It means that whenever I reach null, so if the reference L is equal to null, it means now I can add the element. So I will try to allocate some space in the heap. So list malloc size of struct node, and of course if there's no I couldn't allocate some of the memory, I will return 0. Otherwise I will place in data the number, and next would be equal to null, and return 1. Otherwise I need just to insert the element on the next cell. So return insert list. So I will copy these. So I will keep the same element. However, here I should go to dereference L arrow next, and all I should supply the address of this. So, and this is for the insertion. It's very easy, and we just need here to do the printing. So again, I will need I for looping over the list. I will use an auxiliary list so that not to lose the pointer. And what else? So maybe just these. So I will loop over the array. So let's print index, printf, index percentage d. We have here I, and then let's say that in auxiliary I will place the head of the list, a reference to the list, and then I will loop over aux. So as long as aux is different than null, I will print the aux arrow data, and I will move to the next cell. So aux equal aux arrow next, and just print f here after each printing. So, and let's run and see if we could have the same output. So yes, we have the same output. So it's a very easy exercise. We just need to insert an element into the corresponding linked list. And this is it for this exercise. If you have any questions, do not hesitate to write to me and I will answer you back. And again, thanks for watching.